what that derivative, what the derivatives can tell us about the shapes of the graphs of functions. And so let's start here on the handout there, graph number 1. I'll sketch right here, close as I can. All right, so that's our y equals f of x graph. Okay? Where this here is -2, and then that high there is 3. What are -2 and 3? What do we call that on previous sections there? What do we learn about? At -2 and 3, we have what are known as what type of numbers? Critical numbers, right? Yeah, they're critical numbers. They're local min and max. That's right. So x is -2 and 3. Those, by previous, we saw that those are critical numbers. Why? Well, critical numbers have derivatives equal 0. One of them, one of the options there. Of course, we have critical numbers where it does not exist too, but at these cases we have derivative equals 0, slope equals 0. So those are critical numbers at -2 and 3. And then, yeah, we have the local min and max thing too. We'll get to that, but for now, just know them as critical numbers because kind of approach it here a little bit separately. What we can think of this graph being divided up at these critical numbers. So I've got a part of the graph less here than -2, the part between -2 and 3, and the part greater than 3. Okay, so we've got three different parts to this graph. And so just looking at the graph in those parts, do you see here those critical numbers separate the graph into increasing and decreasing parts? We talked about increasing and decreasing way back. I think it was the very first day. So we're revisiting that here a little bit. And remember what it meant to be decreasing as far as the graph is concerned? If you go left to right, we see that this graph is decreasing, isn't it? Meaning the point, the general trek is downward here. So we've got decreasing. It's a decreasing part there. But what happens at -2? At -2, it turns around, doesn't it? At -2, then, what is the graph? It's increasing, isn't it? We're headed upwards. So we've got increasing there. And then what about at 3? It turns around again, doesn't it? After 3, we've got decreasing once again. Okay? And so one other thing we haven't mentioned here is, now we are, that the critical numbers also usually divide the graph into increasing and decreasing parts. All right? So that's one thing about it. Now, another thing we haven't talked about in the length here between, so the critical numbers also divide up the graph into increasing and decreasing parts. So that's going to be useful because that is what we're going to use here. Now, the other thing to tie in here is the decreasing and the derivative. What's true about the derivative on the decreasing part? Have we mentioned that yet? I don't think so. Now we are, though. Okay. What's the derivative on this decreasing part? Well, derivatives are slopes of tangents. So if I draw tangent lines over on this side, what kind of tangents do I have? What kind of slope? Negative slopes. Therefore, negative derivatives? Yeah. On the decreasing part of a function, the function is decreasing, the f prime is negative, less than 0. If it's an increasing part, well, the derivatives are positive slopes. We have positive slopes, so the derivative is positive, or f prime is greater than 0. Yeah. Okay? And so this is, I think they might call it the increasing-decreasing test for a function. You know, we're not always going to have the graph there at our disposal. A lot of times we can graph it, but even if we don't have the graph at our disposal, we can tell a lot just from the critical number. We can tell about increasing and decreasing just from the critical numbers, and then looking at what the derivative says we've got, positive or negative. So if f prime of x is greater than 0, then f is increasing. If f prime of x is less than 0, negative, then f is decreasing. That's basically what I just wrote there, but more formally here. Okay. All right. And then so tying that with the critical numbers there. Now, at the critical numbers here in this particular case, what about the, is it increasing or decreasing at the critical numbers? At the slope is 0. Well, if your slope is 0, if f prime is equal to 0, is that increasing or is that decreasing? It's not, okay. It's not increasing and it's not decreasing. It's 0 because it's not a positive slope, it's not a negative slope. So it's not increasing or decreasing at those critical numbers, at the f prime of x equals 0, okay? So don't include those. Here's what I'm saying. Yeah, if you've got a 0 slope, that's not positive, that's not negative, that's 0. 0 is neutral, right? So it's neutral as far as increasing and decreasing. It's kind of in limbo there. But here's what I'm saying then with this. When I go to write, so for this graph, the increasing parts, well, there's only one increasing part. The increasing part goes from where to where? It goes from -2 to 3. What about at -2 and 3? Is it increasing at -2? No, it's 0 at -2, the slope is. It's 0 at 3, so do I want to include -2 and 3? No, I don't. So I use parentheses. That's what I'm saying. Don't include the endpoints when you say it's increasing. Decreasing, well, we've got two parts there. It's increasing from -2, well, from -infinity to -2. And then it's increasing from 3 to infinity. So, and don't include the endpoints there either. Okay? All right. So, let's do one here. Here's what we're going to do with, one thing we're going to do with these when we get to just regular functions. I mean, this one, we could probably figure out the graph here, but x squared minus 5x plus 30 is a pretty easy one. We'll get to some more complicated ones here in a second. But by using this increasing and decreasing test and the critical numbers, find where the graph is increasing, f is increasing, and where it's decreasing. Okay, so like we said, when we don't have the graph, we're not going to graph this one, we're just going to talk about the graph of it. Start with the critical numbers because those critical numbers divide up the increasing and decreasing parts. Okay, so here are the critical numbers. How do I find the critical numbers? Well, that's what we worked on last time. Critical numbers are where derivative is 0, derivative does not exist, right? well, there's not going to be, for this one, there's not going to be, there's not going to be any that do not exist. So it's just going to be where the derivative is 0. So what's the derivative? F prime of x equals 2x minus 5. And so the critical numbers, I'm going to set that to 0. And that's not too bad. Add 5, divide by 2. 5 halves is my critical number. So here's how we're going to do that. We're going to divide up the graph. I'm not actually going to graph this, but I'm going to divide up the graph. Just have one critical number. So, but at 2.5, right, that's 2.5. I'm going to break up the graph into those parts, because what we saw was on one side it's something, it's increasing or it's decreasing, and then on the other side it's either increasing or decreasing all the way through, right? It's not going to be increasing on part of this over here and then decreasing. The critical number is divided up. So it's either increasing or decreasing on this side, and then it's increasing or decreasing on this side. Now how do we decide? Well, the way I decide on this side is look at, check just one value on each side. Check one value of the derivative on each side of your critical number. That's all you have to do. And that'll tell you everything you need to know. All right, so f prime, I'm going to do f prime on this side. What would be a good one to choose on this side? Well, since 0 is on this side, I'm going to do f prime of 0. And I'm doing f prime now. So f prime of 0 is 2 times 0 minus 5. Hey, that's negative 5. What does that tell me about increasing and decreasing? Well, the derivative is negative, so that's downward trend, isn't it? With me? Okay. What about the other side? Well, on this side, since this is 2.5, look at 3, the next best thing. Next one over. What is f prime of 3? Well, 2 times 3 minus 5. This 6 minus 5 is 1. Hey, that's positive. So that tells me the slope is positive. It's positive at 3, but isn't it going to then be positive at 4, 5, and beyond? Because the critical number is where it divides up. So the slope is positive, so it's a general upward trend for our to the right of 5 halves, okay? Okay, so with that being said, where is our increasing part then? Well, it divides up at the critical number, which is 5 halves or 2.5, whatever you want to write there. So 5 halves to infinity, increasing, decreasing, well, it'll be negative infinity to 5 halves. With me? Like I said, that one's probably an easy one.